Okay, guys, we're going to do solving systems. These are nonlinear. These are not lines, but we're still going to use the elimination method, so it's going to kind of feel like what we've done before. So it's going to feel like regular elimination. So in a regular elimination, we want one of the variables to disappear, or to cancel out, or to eliminate. And so we're going to do this. I'm going to use the y's. I'm going to try to eliminate the y's in this situation. And so I'm going to call this equation A and this one equation B. And I'm going to eliminate the y's. And so if I do A times 2, that's going to give me the new equation 8x squared minus 6y squared equal negative 22. Let me check to make sure that's right. 2 times 4 is 8, 2 times 3 is 6, and 2 times 11 is 22. Okay, and then I'm going to do the B equation times 3. Okay, and so 3 times 6 is 15, 3 times 2 is 6, and 3 times 38, oh, I'm going to have to go to my scratch paper, 114. Okay, so now I'm going to add those together. That's why it's also called the addition method. And the y's eliminate. That's why we call it elimination method. And I get 23x squared is equal to, back to my scratch work, 92. Divide both sides by 23. I get x squared is equal to 4. And so using the square root method, I'm going to get x is positive and negative 2. Okay, so I did the elimination method, but now I'm just a little bit different than before. So now when I plug back in, I've got 2 x's to plug back in. So when x is equal to positive 2, this gives me 4 times 2 squared minus 3y squared equal negative 11. And then when x is equal to negative 2, we get 4 times negative 2 squared minus 3y squared equal negative 11 as well. I could have used the second equation. It doesn't matter which one I plug back into. So when I finish this out, I get 4 times 4, which is 16, minus 3y squared is equal to negative 11. Subtract 16 on both sides. And I get 3y squared, negative 3y squared is negative 27. So that's y squared equal 9. So I get y is positive negative 3. I'm going to get the exact same thing when x is negative 2. I'm going to get the exact same thing because a negative 2 squared is still 4. So I'm still going to get 16 minus 3y squared equal negative 11. So I also get y is equal to positive and negative 3. So now my answer. Well, when x is 2, I get positive 3. And when x is 2, I get negative 3. And so that is my pair of answers for positive 2. And when x is negative 2, I also get 3. And when x is negative 2, I also get negative 3. So for my answers, I have 4 points. 4 answers. Okay, so again, we're using the elimination method, or the also known as the addition method. So again, this time, the examples, these are nonlinears. And so if you look at this equation over here, I can call this one A and this one B. I can eliminate the xy combo and keep the x squareds. If I eliminate the x squareds, then I'm still not in a good situation. So what I want to do is I want to take the A equation and multiply it by negative 2. And I'll get negative 2x squared minus 2xy equal negative 30. And then the b equation, I'm going to leave it alone. And so now when I add these two together, the x, y variables cancel out, and I have negative x squared equal negative 36. So that means x squared is 36, which makes x positive and negative 6. Alright, so now when I plug back in, when x is positive 6, I'm going to get 6 squared plus 6y equal 15. And then when x is negative 6, I'll have negative 6 squared minus 6y equal 15. So I'll solve both of these and get my other answer. Okay, so this will give me 36 plus 6y equal 15. We'll subtract 36 on both sides. And I get 6y is equal to negative 21. Divide by 6, and I'm going to get y is negative 7 over 3. So when x is 6, I'm getting negative 7 over 3. Alright, for the next one, I'm still going to have 36 minus 6y equal 15. Oh, wait a minute, it's minus 6y this time, so we have a sign change. Subtract 36 on both sides, and this time I'm going to get a negative 21, but when I divide, this time I divide by a negative 6, so for my y, I'm going to get a positive 7 over 3. So when x is negative 6, I'm getting positive 7 over 3. So these are my answers for this one. Alright, now on this other one, we're going to do elimination again. This time, this is A and this is B. I'm going to leave A alone. And then I'm going to do negative 1 times B. So that'll give me a 3. Wait a minute. That problem's copied wrong. Correct. Let's erase that. That's not supposed to be an x squared. That's supposed to be, oops, can't erase it. That's supposed to be an x to the third. Alright, that's supposed to be an x to the third. Okay. So now negative 1 times b would give me a 3x squared minus y equals 0. Now the thing is, these are not like terms. The y eliminates, but I have an x to the third plus a 3x squared equals 0. The x's are not like terms, so when I try to add them together, I can't. So now I have to solve this. Now this can be solved by factoring, because I can GCF an x squared, and then I can take each factor and set them equal to 0 and solve. And the first one I get, of course, x is 0. So I'm going to have an answer with x is 0, and I got to figure out the y. And then I'm going to subtract 3 on both sides. I get x is negative 3. And I'll have an answer when x is negative 3. Alright, I'll plug those back in. So when x is 0, 0 cubed plus y equals 0. Well, that's just y equals 0. So there's my answer when x is 0. And then when x is negative 3 cubed plus y equals 0. Well, that's negative 27 plus y equals 0. Add 27 to both sides, and then y is 27. So those are my two answers for this one.